Okay, so question 45 asks you for this molecule squalene that has a particular formula. How many pi bonds does that molecule have? So please notice that the question is not asking you what is the structure of squalene, how many triple bonds does it have, how many double bonds does it have. It's asking you very simply just, how many pi bonds. So that could mean almost anything. That could mean it has a carbon-carbon double bond. It could have a couple of carbon triple bonds. You just don't know. So you have to keep in mind the context of the question, which is very simple, very, very simple in context. The way we're going to calculate the pi bonds is by just a very simple formula. And we may or may not have talked about this formula yet, but it's a formula called degree of unsaturation. Okay, so degree of unsaturation. Okay, so this is a very simple equation, and depending on who presents it, they may present it in slightly different ways. So this is just the way that resonates best with me, but there are multiple ways to draw this formula out. So the degree of unsaturation is going to tell you how many number of rings and how many number of pi bonds the molecule has. Okay, so the formula for this guy is going to be the number of carbons minus the number of hydrogens divided by 2 minus the number of halogens. So that could be, fluorine, chlorine, bromine, iodine, any of those. So I'm just going to abbreviate that with X, and that's going to be the number of those divided by 2, then plus the number of nitrogens divided by 2, and then plus 1. And the bit that people always forget, always screws them up, is this plus 1 portion. So don't forget the plus 1 portion. Okay. So let's go ahead and fill in the equation. So this is going to be 30 minus 50 divided by 2 minus 0 divided by 2 plus 0 divided by 2 plus 1. So these guys cancel out, and we're going to have 30 minus 25 plus 1, and then we're going to have 5 plus 1, so that's going to give us 6. So overall, this molecule, because of the way that the question is phrased, the way that it's phrased, we can say that this molecule has 6 pi bonds. If you look at number 45 in your book, the way that it's phrased is that it says squalene is an acyclic compound, which means that it's completely linear. So that means every degree of unsaturation must result from a pi bond. And this is a very important bit to remember. Because whenever you calculate degree of unsaturation, what you're really calculating is the number of pi bonds plus the number of rings in a molecule. And keep in mind that this number of rings could equal 0. So if you know that this is 0, then all you're calculating is the number of pi bonds. So if that's 0, then all you have to worry about is pi. So again, if the problem had not said that we had 0 rings in the molecule, that could have been any kind of combination of pi and ring. So we could have had 1 pi bond and 5 rings. We could have had 2 and 4. Any kind of combination of that. We could have 0 and 6 if the molecule did not, or if the question did not say. Okay, so just keep in mind that whenever you calculate du, there are many different ways to combine the number of rings and the number of bonds. Okay, most of the time though, if it's a huge number like this, the question will bias itself. So it'll usually say, it's an acyclic molecule, or it's, a totally saturated molecule, just so you have an idea of where to go. Okay, and again, it is impossible for you to know the structure of squalene just from this. Later on, especially in organic 2, you get a little bit more structure, a little bit more schooling in how to actually figure out structure. And so, whenever you talk about proton NMR, carbon NMR, IR, UV, all of that stuff will help you figure out, detailed structure. But for now, this is all we can really say. Okay. All right. Next question.